In the last lecture module, we saw how to modify the subject class of our premise diagrams in order to extend our effective decision procedure from Boolean direct inferences to the combination of Boolean direct inferences and Aristotelian direct inferences. Now we want to express our effective decision procedure in terms of a set of steps that we also introduced when we introduced that original flow diagram of the process of our effective decision procedure. So we always start in Boolean. We start in Boolean because Boolean logic has the contradictory relations and Aristotelian logic has the contradictory relations. Therefore, any argument that is valid in Boolean will also be valid in Aristotelian logic. And so we have evaluated the argument in both logics if it tests positive in Boolean logic. So we begin, we test the argument using Boolean symbolization. We represent what minimally has to be true in our premise diagram in order for the premises to be true. We represent what minimally has to be true in our conclusion diagram in order for the conclusion to be true. We look and see, is what is needed to make the conclusion true also what is present when the premises are true? If making the premises true has to make the world a way that guarantees the conclusion is true, then the argument is valid in both logics and we can stop. If, however, the argument is invalid in Boolean logic and the subject circle of our premise diagram is partially shaded, that is, there is no X anywhere in that subject circle, then we enter an X in the open area of the subject circle and we circle that X to remind ourselves that we're only entitled to that information if the Aristotelian assumption holds. Then we do our comparison again, comparing the conclusion to the premise diagram to see if what is contained in our conclusion diagram, what we need to make our conclusion true, is now also included in our premise diagram. If the argument is valid in that sense, if what I need to make my conclusion true is also in my premise diagram, then I have to go to the class where I introduce that circled X. I have to go to the subject class of my premise diagram, and I have to decide, does that circle represent a class that actually has members? Is the Aristotelian assumption in fact true about that specific class? If it is, then they say that the argument is valid in Aristotelian logic. However, if the argument's validity turns on having a circled X in a class that I determine has no members, then I say that the argument commits the existential fallacy. Remember, the existential fallacy is a fallacy that we commit whenever we use the contrary, subcontrary, or subalternation relationships for classes with no existent members. In other words, whenever the validity of our argument turns on the existence of members of classes to which it refers when those classes have no members. Now, some people think that the existential fallacy is a metalogical fallacy. That is, it's a fallacy resulting from an inappropriate choice of logical framework for one's argument. Other people simply contend that it is a Boolean logic fallacy. It's a formal fallacy in Boolean logic. For our purposes, it won't matter as long as we can identify instances of the existential fallacy and therefore do not fall victim to that fallacy. Now that we've spelled out the effective decision procedure in terms of those three rules, let's go ahead and practice that decision procedure so that we can make sure that we're very comfortable with it going into the test. So let's suppose that we have an argument. The premise is no people are islands. The conclusion is, hence, it's false that all people are islands. Now you may want to stop the video, try and do the Venn diagram using our new generalized effective decision procedure, and then start the video and compare what you did to what I did. So we'll start by drawing in our premise and conclusion diagrams, labeling them as such so that they're easy to keep track of. Do this as though you were doing it for someone else so that they can easily understand what you've done. The left-hand circle, always our subject class. So we take a letter that represents the subject term and we label that left-hand circle the subject class circle with that letter. Same story with the right-hand circle, always the predicate class. We take a letter from our predicate term and use it to label our predicate classes in each of our diagrams. Now we're ready to fill in our diagrams. Let's start with our premise first. No people are islands. We're starting in Boolean logic. In Boolean logic, we make no assumptions about whether or not there are people or whether or not there are islands. So we say, look, I don't know if there are any people. I don't know if there are any islands. But what minimally has to be true in order for no people or islands to be true is that there can't be anything that is a person and an island. There is nothing that is both, and therefore that intersection, the overlapping area, area 3 in my premise diagram, that would have to be empty because there can't be anything that is in both classes. So I shade that in to indicate that that has to be empty. And because I'm in Boolean logic, that is all that I need. That is the minimal way the world has to be in order for that premise to be true. Now I go to my conclusion diagram. The first thing that I should notice about my conclusion statement is that it is a negation of a standard form categorical statement. It says that universal affirmative, all people are islands, that is false. So I should remind myself what it would take to make that embedded standard form categorical statement true. If I'm being a good Boolean, I say, look, I don't know if there are any people, I don't know if there are any islands, but here's what I know. Everything that's a person, if this statement is true, is also in that islands class, and therefore that area 1, P and only P, that would have to be empty. That's what it would take to make that embedded standard form categorical statement true. All people are islands. My conclusion is a negation of that. It says that embedded standard form categorical statement is false. It's false that all people are islands. So to symbolize what minimally has to be true in order for it's false that all people are islands to be true, I have to make sure that all people are islands can't be true. Area P and only P, area 1 there in my diagram on the far left, has to be empty. Then if I put an X in, that guarantees that it is false that all people are islands. And that is the minimal amount that the world has to give me in order to make sure that that conclusion, it's false that all people are islands, is true. Now I can look at my premise diagram and look at my conclusion diagram and decide, here's what I need to make my conclusion true. Here's what I have when my premise is true. Does making my premise true guarantee that the world is the way such that my conclusion would also be true? So to make my conclusion true here, I need an X in P and only P. I look over at my premise diagram and I say, well, no, that area is indeterminate. I'm not committed to anything about that area in making that premise true. And therefore, it's possible for the premise to be true without guaranteeing that the conclusion is true. And so this argument is invalid in Boolean logic. So again, I would write that down explicitly, trying to execute this effective decision procedure as though it were a demonstration for someone else. Since this argument is invalid in Boolean, I now want to test to see if it's valid in Aristotelian logic. I don't have to worry about the conclusion diagram. I don't have to worry about the predicate class of the premise diagram. I only have to worry about the subject class of the premise diagram in my direct inferences. And so I look at that subject class of my premise diagram, P, and I say, is there an X in there? Does it satisfy the Aristotelian assumption? Well, there isn't an X in there. And so I modify the diagram. I introduce an X, and I circle the X to remind myself I'm only entitled to suppose that there's a member in that part of the class because of the Aristotelian assumption. Now that I've modified the subject class of my premise diagram, I again do my comparisons. In order for the conclusion to be true, there has to be at least one thing. It is a P, it is not an I. It's in the P circle, it is outside the I circle. Now, under the Aristotelian interpretation, there is at least one thing, that circled X. It's in the P circle, it is outside the I circle, outside of the predicate class, and therefore, making the premise true under the Aristotelian interpretation would guarantee that the conclusion is true. But before I write valid in Aristotelian, I think to myself, I need to check and make sure that this argument doesn't commit the existential fallacy. Does that subject class actually satisfy the Aristotelian assumption? Does it have members? So I look at that class. People, there's a few around, so I'm fine. So I can go ahead and write in valid in Aristotelian logic. I want to introduce one more example in a brief lecture module for the next lecture module. And then we'll turn our attention to our second extension of our categorical logic. We'll introduce these translation heuristics for translating ordinary language and situations into our highly simplified formal system.